Hi, my name is Warren Peterson with the Security Certified program. I've been a teacher of technology courses for a long time, starting with Windows NT courses. I've taught all the various Microsoft courses, Cisco and CompTIA courses, quite a few security courses, and I've written many of the security courses, including the ones for the Security Certified program. And today we're going to get into the Strategic Infrastructure Security course. On the Strategic Infrastructure Security course, we'll begin with the discussion of cryptography and how this relates to data security. Cryptography is the core of many advanced security systems, so a solid understanding of how that works is essential. From there, we'll move into the hardening of both Linux and Windows Server systems. Using these two operating systems is required for most security professionals. Running in a single operating system environment isn't very productive in most business organizations. And we'll take a look at some common attack techniques. It's not a detailed lesson going into every single type of attack, as there are many other security courses that address that. Rather, it's a look at how common attack techniques work and function. From there, we'll move on to Lesson 5, discussion of security on the Internet and the web itself, including things like DNS security, web server security, and how users can make their environment more secure. And we'll look at how do you perform a risk analysis for an organization, and how do you create a security policy for an organization, key things in the overall security of the network environment. And lastly, we'll take a look at how do you analyze packet signatures, the network traffic that's coming into your organization. When you capture it, how do you actually analyze what type of traffic that is? Now in this lesson, managing and examining cryptography, we'll start with a description and analysis of the history of cryptography, different cryptographic systems over the years, and take a look at how they function. From there, we'll move into a look at how math and cryptography works together. Math is required to have an understanding of cryptography and the various algorithms that are used. We'll look at the private key cryptography systems. And from the private key cryptography systems, we'll move on to public key cryptography systems. So once we've looked at both of those types of systems, we'll lastly look at how message authentication functions in the network and how that's relevant to your cryptography. Topic 1A discusses the history of cryptography. We'll take a look here at where cryptography systems came from. And the beginning of that is a discussion of keeping secrets. Now, why are secrets required in the first place? Sometimes people will say, I don't use any sort of top secret information, so why do I need cryptography? Why do I need encryption on my network? Well, if you ask this person, can you tell me your social security number, your bank account number, your telephone number, driver's license number, all sorts of information that people do want to keep secret. So everybody has some level of information that they need to keep secret or private to themselves. And for businesses, for companies, there's quite a bit of information, proprietary information that you don't want your competitors to know. So everyone has some level of some information that they need to keep secret. And the way you do this is through something called a lock and a key. Now, the traditional lock and key analogy works pretty well for cryptography. There's a lock and a key. The lock would be the cryptographic algorithm, and the key is the way that algorithm works. And we'll take a look at all of those as we go through this lesson. Now, one of the things that you'll see a lot throughout cryptography books, including this one, are the names Alice, Bob, and Eve. Now, this comes from user A, user B, and Eve for eavesdropping. So when you have a message being sent from user A to user B, this is frequently referred to, and will be in this course as well, as Alice and Bob for user A and user B. Now Eve then becomes the person trying to get that message, trying to pull that message off the wire, the one that was sent from Alice to Bob, and try and eavesdrop on that and listen to that. So if we take a look at our first analogy, which is using the traditional number lock, the combination lock. The number lock analogy is a pretty simple analogy for how this works. You can have an attack at the actual mechanism of the lock itself. Is it clipped around a bar, for example? Or you have an attack on the actual key. So you have a lock and you have a key. The number of values and the number of combinations, that's related to the key strength. So do you have a lock that just has one of 4 combinations, or do you have a lock that has multiple combinations? And you can move on further and have a traditional lock that has 3 or 4 different combinations that have to be set in sequence. So the attack can occur physically. Maybe the lock is put on incorrectly, or somebody could try and break it open. So it has to be made well. And then the key has to be strong. So if we were to compare this to cryptography, your algorithm, the actual lock itself, has to be made well. It has to be one that can't break easily. And then the key that's used needs to be complicated. You'd rather have a key that's one of 48, for example, versus a key that's one of 4. Some of the basic cryptography terminology that's required. The first one, the cryptographers. So this is the group of people who create the algorithms, create the cryptography systems in the first place. The cryptanalyst is the one who's trying to decode or decipher encrypted information. Cryptology in general, that refers to the actual science of cryptography, encryption, and decryption. Plain text is the message you have before it's sent through your encryption system, before it goes through the algorithm. And your ciphertext then is the result of that. So if you send a plain text word to the algorithm, the gibberish that comes out the other side, that's the ciphertext. Then encryption and decryption, simply to encrypt or decrypt, sometimes you'll see that listed as encipher or decipher as well. So encryption is the act of making the ciphertext from the plain text, and decryption is the reverse of that. You have the ciphertext, you decrypt it so your result is the plain text information.